this unit is, this is my favorite unit of probably all of Math 30, both in 30-1 and 30-2, and it's the logs unit. Now, you will love this unit if you know all the rules. You will hate this unit if you do not know all the rules. It's very polarizing. If you know 75% of the rules, you do not know all the rules, you will not do well. Okay? And there's just tons of rules for the logs unit. Now, what are logs used for? So I want to talk about that first. So this sort of has some meaning when we're going through them. But even in the last unit, we were doing, yes, I'm taping. Yes, I am, thank you. 3 to the x equals 9. What's x? Okay, x equals 2, right? How about 3 to the x equals 10? How would we solve that one? y1, y2. Okay? So what would it be if you y1, y2 it? 3 to the x in y1, 10 in y2. As soon as you get it, yell it out. What are we getting? Nothing? No, it's not 3.33 because 3 cubed is 27, so it can't be that big. 2.096. Okay? Now, here's the beauty of logs. If you gave me this, 3 to the x equals 10, I'm going to put this in log form. Log 3 to the 10 equals x. Actually, my 10 is a little high, so 3 to the 10. And the way you do this, you get out your fancy calculator, which mine's loading up. And all you do, you see this log button right beside the 7? Right here, you guys see it? So you go log 10 divided by log 3. And that will give you the exponent. Up to now, up to your whole grade 1 to 11, the only way you've been able to find exponents is by guessing and testing, and then y1, y2. The problem with y1, y2 is it needs graphing, okay? And the actual answer is this. This is the real answer. Log 3 of 10. That's if you're going to launch something to the moon, you better go to 20 decimal places. Okay, or else you're going to miss the moon. So the 2.096, right, that is just an estimate. But log 3 of 10 is the exact value of x. So now we can find exact values of exponents. So, yes? The 10 and the x switch. Do you see this? And then I put log. So I kept the base the same, put log down. That's one of the rules, right? You can go from exponential to log notation, quite easy. Now, we still have to know, because we're going to be doing log regression, right? So regression in the first unit, right? We did exponential in the second, and we're going to be doing log regression in the third. So I want you to know, well, what does this graph even look like? Okay, define a logarithmic function. So it sounds like a big, ugly, scary word, but it's not. It's actually an awesome tool. Now, if you don't know how to use the tool, then it's frustrating, right? Obviously, my goal for you is that we know how to use it really well. So it is a function. So we want to get the definition, because you know one of these are going to be on the test, in the form y equals a log, the b is like a little subscript, and the x is on the same level as the word log, where here's our a cannot equal 0, b cannot equal 1. What's that? So A stands for this, A. B cannot equal 1. And you'll see why. B has to be greater than 0 as well, so we'll put it on this line. So B cannot equal 1, and B is greater than 0. And X has to be greater than 0. And a cool thing that you're going to learn, and here's a rule, but you can take this A and put it here anytime you want. Y equals log bx to the A. So there's a lot of cool tricks you can do. In some of these questions, there's up to 4 ways to do the same question. Do I want you to know all 4 ways? Yep. Because the better you are at doing it all 4 ways, the better you're not going to make a mistake on your test, right? You're going to be able to catch it. Now, using graphing calculator to graph y equals log 10 of x. Now, just so you know, the 10 here is always implied. You know, like this, square root 5, the 2 is implied there, right? If you just see log x, these mean the same thing. Okay, so there is an invisible 10. Okay, are we thinking about all the things that can be going on a study sheet already, right, for tomorrow's quiz? Because you get to use your study sheet for all your quizzes. Now, hey, if you get 100% on your quiz, you got 100% in your quiz, right? Doing a study sheet's going to help you even do that. So we're going to try to be proactive, right? So there is an invisible 10 there, so let's graph it. So we got in graph, clear this, clear this. All we're going to do is log x. Like, what does a log graph look like? Okay, so hit graph and hit zoom 6. Like I should have done in the first place. Zoom 6. Okay, so this is what a log let's get that down here. Where's my paste? So I want you to kind of draw that the best you can. And I'm going to draw it in red because this isn't doing a very good job. But it does come along here. And then it goes through 1. So your x int equals 1. And it's going like this. Okay, now we have just graphed this. Okay, we can even draw it underneath. It goes like that. And let's graph y equals 10x. Okay, so I can clear this. So 10 exponent x. Okay, and again, just draw that really quick. Now, because it's a widescreen calculator, the x's are a bit more spread out than the y's. So it may not look like it, but if I did this, so I'm going to go, I'm actually going to put log x on this graph as well, so I can see, you can see them at the same time. So log x, and instead of zoom 6, I'm going to hit zoom square, which is 5. Okay, and again, take a screenshot, put it down here, because I think it's kind of important to see what's going on here. But this one is going like this, and it goes through y equals 1. This one is going like this, and it's going through x equals 1. Now if you did this, so I want you to draw, this is called the line y equals x. 1, 1, 2, 2, 3, 3, 4, 4. But you see they're a reflection of each other on that line. Okay, because they are a reflection on that line. And what happens when you reflect it? Now, let's look at our chart. 10 to the x. What's the domain? X is in the reals. What is the domain of the second one? Okay, throw it out there. No, domain is x. So it should be x is greater than 0. It will not touch that y-intercept. Okay, let's talk about the range of y equals 10 to the x. What's the range? What y values? Okay, here I am. Cruise along, and then I'm going like that. So, am I doing any negative y's? Okay, how about 0? No, so that what would be the domain? Y is not ER. Y is greater than 0. What is the range of this one here? Y is in the reals. Now this doesn't look like it, but it's going to keep going and going and going, right? So y is in the reals. What do you notice has happened so far between the two graphs? They are opposites. They have traded. Okay. Wonder if there'll be a question on test about that, right? What's the x-intercept of y equals 10 to the x? The x-intercept. Okay. Show me where it's going through the x. Is it? No. There is no x-intercept. It's never going through it. How about the x-intercept of y equals log 10 of x? It's 1, right? Now let's go back to our top graph. What was the y-intercept of y equals 10 to the x? Let's even put it in coordinates. It's 0, 1. This is 1, 0. What is the y-intercept in log 10 of x? None. Okay, do you see how those switched? The asymptote is the line that it gets closer and closer to but never touches. In the first case, this is my asymptote. It will never touch that line. So what do we call the equation of that line? No. Any horizontal line that we've ever been doing. No, it's the x-axis, but it actually has an equation. We've been doing them like crazy in the last y equals 0, yeah. Right? Remember y equals 5 would be this line? Remember that? Okay. So, and then the asymptote for the other equation is x equals 0. Yes. Oops. That's not good. Come back. Okay, lots of stuff to know there, right? We want to get that stuff on our study sheet. Okay, now let's just talk about log. Let's do y equals 1 log x. Okay, so we'll draw it at the very end. Well, that is the same thing as this, correct? I get rid of this. Like if I put a 1 in front, it shouldn't change it, right? Second, 1 log x. Right, there it is. So, again, we'll draw it like this. It's going through 1, 0. What is the end behavior? Good. 4 to 1. This is quadrant 4. This is quadrant 1. Domain of this. Come on, we can do this quick. What's the domain? No, x is not in the reals. Okay, I can't even cross that y-axis. How am I going to get all those other x's? Okay, what's the range? Y in the reals. What is the x-intercept? It's right on your graph there. What is the y-intercept? None. Okay, now they want to ask us, well, what would y equals 6 log x look like? It's a good question. Let's try it. So I got that. I'm going to put a 6 here. What happened? How would you describe what just happened there? It got more steeper. It's still going through 1, 0 though. Okay, so by looking at that graph, what is the domain? X in greater 0. Range. Y is in the reals. X-intercept. 1, 0. No y-intercept. And end behavior? 4 to 1. Okay, now let's try this. Y equals negative log x. So I'm going to put a negative sign in there. What do you think happened? That's what we call a reflection on the x-axis, right? Now it went like this. Actually, I want to go nice and steep, right? It was a bit steeper. Okay. Domain. Did my domain change? X in the reals. Range. Or not x in the reals. X greater 0. Range. Y is in the reals. Number of x-intercepts. So, oh, actually it didn't. Yeah, okay, and y-intercept? End behavior. 1 to 4. Okay, so here's a little subtle thing. This became a reflection on x-axis. That means that's our mirror. Right? That became our mirror. So they want to know if A is positive, so that would be my 6 log x. As x increases, what is y doing? Is y getting bigger or smaller? If A is positive. As x increases, y increases, right? They're all positive values, right? Right? Just look at it here. As x gets bigger, so does y. If A is negative, as x increases, let's draw our graph right here before you answer this one. What's happening with y? It decreases. It's getting more and more negative, isn't it? So y decreases. Now there's always some things they throw into a curriculum that you're like, why, really? But what is in the curriculum is what we call natural logs, okay, which is ln x. Now ln x is the same thing. So if I had y equals ln x, this is the same thing as y equals log e to the x, or e of x. So ln equals log e. Now e is Euler's number, and it's a whole can of worms to even explain that to you, but if you do the derivative of it, and there's a limit function, right? But I don't want to get into limits. I just want to introduce to you this log e, and the ln button is right there, okay? So you could use log, and here's your e. So if I just did this, like, I'm just going to get out of here. So if I did ln 6 equals, that would be the same thing as log 6 divided by log e. Should I get the same answer? Oops, did something wrong there. Oh, put a division sign instead of. My second, it didn't work. Second. Okay, so you get the same answer because log e is the same thing as. Now, log e, if log e to the x equals, say, y. Now remember, these two can trade, so e to the y equals x. Okay? Now, that's just why they're related. So, to come all the way back, this one's so tough. Like, I'm like, how much do I show them? I don't want to confuse the crap out of them. This is what you need to know. This is what y equals e to the x equals, and this is y equals ln x. So I needed to talk to you about that e because we knew that we knew the other two, right, 10 to the x and log 10 of x were mirror images. Well, ln x and log e to the x are mirror images, because this is really log e to the x, okay? So we want to talk about the behavior of ln x and, okay, now let's do the function y equals ln x. Now, if you graph that one over here, it'll look like this. And let's just, I want to just put ln x in for you, so it doesn't look like I'm making this up. Okay, and we can still see it's going through 1. So if I go y2, I'm going to make equals 0. You can't see it happening, but if I want to find my intersect, second trace, 5, enter, enter, enter. Did you not graph? y2 equals 0. This is a bit anticlimactic here. There we go. Okay, so this is still 1, 0. So ln x, what do you What can you tell me about the domain? X greater than 0. Range. Y is in the reals. Number of x-intercepts, or what is the x-intercept? 1, 0. The y-intercept. End behavior. 4 to 1. Okay, now y equals 4 ln x. What happened last time when I put a 6 in front? What did it do? Made it steeper, right? Still going through 1, 0. But by looking at it, what's my domain? Range. Well, it's in the reals. 1, 0. Y-intercept, none. 4 to 1. So we're trying to see what changes, what doesn't changes. Now, y equals negative 4 ln x. What are we expecting to happen? A reflection on the x-axis. Okay, what is the domain? X is greater than 0. Range. Y is in the reals. X int. 1 comma 0. Y int. None. End behavior. 1 to 4. So again, this is reflection on x-axis. So this is stuff that you have to like memorize, right? Memorization is the lowest level of learning. But do you have to memorize it, or can you put it in your calculator and go, oh yeah, that's what it does, right? So you just have to know how to put it in your calculator and then know how to read from that, right? And don't get these mixed up, right? That's the problem. We've got to make sure. So what do we know about the two graphs of, see, I don't want, we just talked about that already. So this is all the same, okay? If A is positive, as x increases, y increases, right? Identical to the last page. If A is negative, as x increases, y decreases. Okay, based on the observation, which characteristics of graphs of logarithmic functions are similar or different to the characteristics of graphs of exponential? So exponential will always go like this, right? Logs, if it's a positive log, will always go like this. If it's a negative log, that's going to be, but these will always be a reflection on line equals x. We call this y equals x because it's y equals x there. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. That's when x equals y. Y equals x. That is the y equals x line right here. Because that's where y equals x. This is an exponential here. This is a log function here. So these two graphs are always on the reflection line y equals x. So this may be something that they will give us. Y equals log a log x, or y equals a ln x. What if a is greater than 0? What's the one word in math that means that? A is great. It's positive. Okay? What is the end behavior if a is positive? 4 to 1. If a is less than 0, negative, it would be? Okay. They will need you to know that on the diploma. So make up a question for yourself. Put in a positive a, positive 4. Put in negative 4, right? Look at the end behaviors. Is it faster if you memorize it? Of course it is. Is it less reliable? Of course it is. Right? So You can put it in your calculator. I just showed you it works, right? I mean, just to do a fast picture, right? This one goes like this. And when you put in it goes like that, right? This is quadrant 1, this is 4. This is quadrant 1, that's 4. So the one's going from 4 to 1, the other's 1 to 4. Okay? So I'm really drilling this in. I apologize, but it's better than going too fast. Today's all about learning about these weird graphs, and then we're going to find out why it's so good. Okay, so key ideas about log graphs. So draw yourself a log graph really fast. The x-intercept is 1. Check. Do you remember this one on the test? It had a whole bunch of these, and you had to pick which ones were true. Remember that? Okay. You don't remember that? It was like almost 5 days ago. Okay, number of y-intercepts. None. Yeah, I get it. End behavior. The curve goes from 1 to 4 or 4 to 1, depending on if A is positive or negative. So it's going to go from 4 to 1 if A is greater than 0, and go from 1 to 4 if A is less than 0. Domain, x in the reals. Domain, x is greater than 0. Trying to multitask here. And there's the range, y is in the reals. So we got to know all that stuff, right? That is going to be on your quiz tomorrow. This stuff needs to be on your study sheet. You need to start seeing stuff that I need on there. Okay? So if A is greater than 0, we say the function increases. So this is why it's increasing. Do you see how it's getting bigger and bigger? This one, the function is decreasing, right? Y gets smaller and smaller and smaller. Okay, have I beat this to death enough? No? Awesome. Okay. So, case 1. A is greater than 0. Does that make sense? Is A greater than 0 in this picture? Yes. In the next picture, is A less than 0? Yes. Okay? Now, the graph y equals log x is a reflection of the graph y equals 10 to the x, about the line y equals x. Did we learn that? Okay, the graph y equals ln x is the reflection of the graph y equals e to the x. Now remember, can you come over here? There was back to this last one, there's an invisible 10 here. Do you see where the 10 and the 10 are? They're the base on both of them. Remember, this is the same thing as log e to the x. Do you see how the e and the e are both bases? Okay, just so you know, this is always going to be my base. That little subscript, it's going to be the base of the log. And it's the base of an exponent. See how this 10, base, this 10, base. Base does not change. Okay. Tomorrow I'm going to teach you way more how to manipulate these. Today's just learning the graphs, taking it slow. Yes? Okay, say that again. Y equals, you said it. Where'd you get that from? Off the top of your head? So, log a to the x, you can switch these. X will equal log, or sorry, will be a to the y. These two are actually equivalent. Okay, if I did this, y equals a to the x, those will be my mirrors. Okay, these will be a reflection on y equals x. That might be, I think, what you're asking right now. Okay, I'm going to get into how to manipulate these tomorrow. I started with that to say, hey, this is going to be cool how we'll be able to find exponents from now on. just to show you why we're doing it. Today, all we're doing is learning the graphs. Okay? Okay, predict the number of x-intercepts, y-intercepts, the end behavior, the domain, and the range of the following. Okay, so I've just been beating this to death without going to our calculators. Where will this one start and where will it end? Okay? Why? Because it's negative. Okay, so what is the x-int? 1 comma 0. Okay, what is the y-int? None. What is the end behavior? 1 to 4. What's the domain? Can't hear you. X is greater than 0. What's the range? Y's in the reals. Okay, now y equals 12 ln x. Where's it starting? Goes from 4 to 1. Going to be pretty steep, hey? Because of that 12. Because it's positive, I drew it like that. X-int, 1 comma 0. Y-int. End behavior. Four to 1. Domain. Range. Okay, do you remember the very first quiz we did on the exponent unit? I had something similar to this, match to the graph. Okay, take 20 seconds, put 1, 2, 3, and 4. Even write the equation. See if you can match those graphs without using your graphing calculator by the rules we've learned over and over and over today. Probably out of all units, this would be the easiest unit to get 100% on a test. If you know your rules. Obviously, that's why we're quizzing every day, to make sure we know our rules. We're going to have a great study sheet, right? We're going to do lots of practice. Because if you don't, you're going to hate this unit. I'll just tell you that right now. I don't know all my rules. People, you know what? Not too many people like people that hate them. Right? So if you're not doing well in your quizzes and if you're not doing well on the homework, of course you're going to hate it. It hates you. Right? Not too many people are, yeah, I really like that person. They hate me a lot, but I really like them. I like hanging around. It's good times, right? It's not how it works. If the math's hating you, people hate it back. Okay? So what would A be and Y? Okay, put up your hand. Tell me what A is, which one, and why. Yes? Okay, 4. Why? It's the only one with a negative. Okay? Y equals negative ln, or negative 2 ln x. Because end behavior of a negative is always 1 to 4. Like, can you even comprehend how impossible tomorrow's quiz is if we weren't here today? Yet, once you see this stuff, right? I mean, if you watch the video, you're going to be okay. But once you see it, it's like, okay, right? But tons of information. I mean, I've been going nonstop on these notes, right? Okay, what is B? Why? It's a log function, for sure. Okay. And it's positive, is it? Right? So this will be y equals positive 6 log x. C. Okay. Is it 1? Why? It's a growth. Who said growth? Good man. Okay, why is it a growth? What's bigger than 1? B. Okay, so this is y equals, that was a long time ago we did that unit, eh? So this is B, growth. 5 days is a long time in math world. Okay, so process of elimination, we know that it's, the last one is decay, right? To 0.1 to the x. This is decay. What is this, though? What's this 5? Y int. What's the 2 here? Y int. Okay, so the homework that we're doing is page 171 to 173. Okay, got a big surprise for you tomorrow. We're going to have a quiz. Okay, yay. If you have your study sheet out, I'm walking around, I'm going to put a bonus mark on everybody that has a study sheet with this stuff on it. See? Austin's already got money in the bank. And then after tomorrow, I want you to add the next one. Then then when we're done, the very last one, you're going to have a study sheet done. Right? That's how I need, right? We got to raise our expectations. What are we trying to get for a final mark? 100, right? If you put all this stuff into place, we can get your mark better than it is now. Okay? Because remember, that mark, that final mark, that just goes down in a transcript. They get that transcript, where you're going, and they add up all, they find your average. If your average is higher than this guy or this girl, you get in. It's that, they don't, oh, they look like a nice person. Oh, you know, look at their picture, let's give it to them. No. It's black and white, mark, right? So, yeah, you know, I kind of had a haircut that back in the 60s. I'm going to do that. I like that guy. He looks like he needs a break, you know? I know he got 50 in math, but he needs a break. This person that got 90, let's pretend, let's lose it. Let's just lose this one, right? Okay, so study sheet done, and I want this homework done for tomorrow. Okay, I've got students writing the test, so we should be able to get it back. It was a good test. Okay, you guys kept your average the same, right? But the unit wasn't as strong because you guys gave up on the... Now, let's be positive. 26 of you got 100 on your quizzes. So it's not like we're like epidemic, right? Well, 26 people got 100 on their quizzes. So they guaranteed those marks, right? But no, we still pulled off a 90 average on the exam. But it's not, we cannot relax. We got to keep going harder and harder and harder. And as soon as you walk out of that diploma, then you can relax. Okay? If I would do you the biggest disservice right now by letting off every unit, we got to go the other way. Okay? So everybody knows what they're doing, right? We don't need to chat. You'll get it done in class. Remember, you get 6 out of 5 if this is done in class. Plus tomorrow, if you have that study sheet, when I come around, you're probably going to get 100 on your quiz, which saves you having to come in at East. You're going to get a bonus mark for your... And then we keep expectations up, right? And if you miss a class, what do? Watch the video, okay? My last school, my students are watching my videos still, right? So they have that extra advantage over some of you that aren't watching at all, and you're like, well, I'm coming in, I'm going to wing it, right? Then you wing it, then you don't do well in your quiz, then you don't come in at East to fix it, right? Then it just becomes... And I get it, some of you don't have internet at home, but if you're fighting for this mark, you come in the morning, you at lunch, and I know you can hang around with your buddies, that would be so much more fun. I get it. It would probably be a lot more fun to go out for your birthday than wait a day. Everyone gets it. No one's going to say that wouldn't be a lot of fun. It's just like consequences, right? Like make good choices that help you. And if your friends are like, well, I'm not going to be your friend anymore because you went and did math, that'd be a good test of a friendship. Might want to get rid of that one pretty quick. Remember I told you about that student I had last semester, the second last unit, they're finally all fed up that they've got the lowest mark in the class on the last test. And I said, what do you mean? Like every East, where have you been? Oh, well, I hang around with my buddies. Well, how's that working for you? Right? So then the next unit, he put everything into place. And I'm not making this up, right? I swear to you, got 100% on that unit exam. Lowest mark in the class, 100 on the next one because he decided to do his homework every day. He did his quizzes every day. And then he got 100 on the test, right? And you guys know, none of you should be below 80. Like that we can't go there. Okay, oh, just so you know, Mr. Weeb is here. I'm kind of wearing two hats today. I'm just working in the office and stuff, so I have him for, he's great with math. He's done it for a long time, so if you have any questions, you can put up your hand too, and he'll help you out. But I think with your study sheet out and these notes, you shouldn't have a problem. And again, we want to make sure that study sheet's only one side, so let's put our name on the back. And write tiny. You don't know what's coming. And then if you have extra room on the bottom, I don't know, draw a picture of your dog or something. Okay, you can fill it up.